Hi guys, welcome to the third section, networking. In this section, we will start with building a secure network. Then we will move to creating a NAT gateway and hosting a domain. After that, we will do canary deployment via DNS and routing based on location with failover. Lastly, we will do network logging and troubleshooting. Now we move on to the first video of this section that deals with building a secure network. In this video, we are going to build a secure network VPC in AWS. The VPC network consists of two public and private subnets split across two availability zones. It will also allow inbound connections to the public subnets for SSH port 22, HTTP port 80, HTTPS port 443. Before we proceed, we need to know the names of at least two availability zones in the region we are deploying to. In our example, we deploy to US East, so to get things moving, you can just use US East 1A, US East 1B. Then you create an AWS account. Your zones are randomly allocated. This means that US East 1A in your account isn't necessarily the same data center as US East 1A in my account. Now we create a new CloudFormation template for our VPC. This will be one of the larger templates. The first two parameters correspond to the availability zones. We don't provide any default values for these parameters to maintain region portability. The shell of our VPC has now been created. At this point, it is not connected to the internet, so it is not entirely useful to us. Now we add an internet gateway and attach it to our VPC. The remaining parameters define the IP address ranges for the entire VPC, the public subnets, the private subnets. The default values we provide for the subnets will allocate 512 IP addresses to each subnet. AWS reserves a small number of IP addresses in our IP space for AWS-specific services. The VPC DNS server is one such example of this. It is usually located at the second IP address in the block allocated to our VPC. Now we can start to define resources. We will start by defining the VPC itself, as well as the two public and two private subnets inside it. Now we need to create a couple of route tables. The first one we will focus on is the public route table. The public route table is assigned to two public subnets we have created. This route table will have just one route in it, which will direct all internet-bound traffic to the internet gateway we have created. Then we will create the private route table similarly. Since the private subnet is isolated from the internet, we don't add a route to the internet gateway. Remember that if you were to follow the NAT gateway, it will require a route table as an input parameter. We will now focus on the security aspects of our network. First, let's see the public subnets. These are the subnets you will add your load balancers to. You will also add things such as bastion boxes and NAT gateways, so we need to add a network ACL with several entries. It allows outbound traffic to all ports. Outbound access is unrestricted from hosts in our public subnets. It allows inbound traffic to ephemeral ports. This ensures that packets returned to us from our outbound connections are not dropped. It allows inbound access to low port numbers for SSH, HTTP, and HTTPS. Now we'll add some lines of code for security in public subnet. We need to do the same for our private subnets. These subnets are somewhat easier to deal with. They should only be allowed to talk to hosts within our VPC. So we just need to add some NACLs, allowing inbound and outbound traffic to our VPC's IP range. Finally, we will add some outputs to our template. These outputs are usually candidates for feeding into other templates or components of automation. Now we save the file as building secure networks. Now we will create our VPC in the web console using this command. Let's run it with availability zone 1 here and availability zone 2 here. You can see the CloudFormation stack being created here. When you run this template, AWS will go ahead and create an isolated and secure network just for you. While it contains a number of resources and concepts which will be familiar to network administrators, it is essentially an empty shell, which you can now go ahead and populate. Each VPC contains a virtual router. You can set it, and you can't log into it to perform any special configuration, but you can customize its behavior by modifying the route tables in this template. The NACLs we have deployed are not stateful and should not be considered a substitution for security groups. NACLs are complementary to security groups, which are stateful and frankly much easier to change and manage than NACLs. Here are some of the main VPC topics we will encounter as we progress with our VPC usage. First is Direct Connect. This is a method of connecting your DC to your VPC using a private and dedicated pipe. Doing this often provides better network performance and may also be cheaper than VPN connection over the internet. Next is Virtual Private Gateway. You can configure your VPC to connect to your corporate DC over the internet via VPN. This requires that you run supported VPN hardware in your DC. IPv6 support was added recently. After that, we have VPC endpoints. This feature exposes AWS endpoints inside your VPC so that you don't have to route traffic over public internet to consume them. Only S3 is supported at the time of writing. VPC peering. You can peer a VPC to one or more VPCs so that traffic can flow between them. The IP ranges must not clash, and while the peering is free, you will still need to pay for traffic between VPCs. Transvestive peering isn't supported, so if you need traffic to traverse VPCs, you'll require a VPN routing appliance of some kind. Cross-account VPC peering is supported, but cross-region peering isn't yet available. Then we have VPC flow logs. You will want to enable VPC flow logs in order to monitor traffic and do any kind of network debugging. Multicast traffic isn't supported. Subnets must reside in a single availability zone. They can span availability zones. Next is Elastic Load Balancers can scale out to use a lot of private IP addresses if you are sending a large amount of traffic through them. Keep this in mind when you are sizing your subnets. The number of VPCs you can deploy is limited to 5 per region per account. You can request to increase this limit if necessary. Internet gateways have the same limit, and increasing one limit increases the other. Last is the default VPC. First and foremost, the default VPC is created automatically for you when you create your account. It has some different properties and behaviors to the VPCs you create for yourself. If you try to launch an EC2 instance without specifying a subnet ID, AWS will attempt to launch it in your default VPC.